now going to unpause it because I'm not going to forget to do that. Hi everybody. I am not Max. I am Ryan. Um, I am going to be your instructor for this week. Today, Wednesday, Thursday, and then we've got your summer break, and then after that, we've got the week after that, and I'm going to be teaching for both those weeks. Um, so just a quick little bit about me. I've been in software engineering for over 10 years. I do it professionally, and I work for a small consulting company called Bread, and kind of work all over the place doing software work for lots of different clients. Um, yeah, I'm also completely self-taught, so I didn't go through like any sort of professional like thing. I just kind of learned on my own. So it's been a bit, but I'm very familiar with sort of the process you all are going through and the challenges and trials and tribulations of it. So yeah. Okay, so what are we going to be talking about during my section? Let me share my screen. Okay, can everybody see my screen? Okay, I'm seeing a thumbs up, so I'm going to call that good. Okay, so we are going to be talking about a number of things: HTTP and APIs, RESTful APIs, JSON, and AJAX. That's the official title of what I'm supposed to talk about. But today in particular, we're going to be talking about networking fundamentals. So overall, the material I'm going to be covering is about networking, about what that is, how we can use it to make more interactive and high quality applications that better serve users. So we got to start with what is networking. I imagine probably a lot of you have heard the term of like computer network or something like that before. But I pulled a definition online that I thought was relatively good. A computer network is any group of internet-connected computing devices capable of sending or receiving data. Most of the things you use day to day on a computer somehow touch with, oh, yes, slides link. Thank you. Should just be posted in the chat. I will also post it in Slack as well. And these slides are for my whole thing. So like it isn't one slideshow per day. It's like this has like 500 slides or something crazy, and we're just going to work our way through it. So just heads up on that. Cool. So computer networking kind of unlocks a lot of the powerful things that you can do with computers these days. So email, web browsing, social media, video calls, a lot of really like powerful, rich applications of computers. And without it, like without getting computers to talk to each other, you're fundamentally just stuck building things that just affect the one computer you're on itself. And that is, I mean, you can still do some cool stuff, but it's not quite to the level of like these more complicated problem spaces. So to try to talk a little bit about like how networking works and a little bit about like some of the important concepts, I've put together an analogy, and we're going to see how it goes. My analogy for networking is like the postal service, or like like USPS. So if you think of like every house in this little diagram being like a computer, and then all the roads being like the wires that connect the computers together. So if you're sending mail from one house to another, you're sort of, that letter's making its way onto the roads. It's making its way eventually from one house to another. And fundamentally, what's happening on the internet, on a computer network, is very similar to that. But we're going to talk about some of how the concepts in this analogy and how the actual computer networking actually works, sort of draw some parallels. Also, I should say, typically the way I find most effective is if anyone has any questions at any time, feel free to interrupt me. I'm very forgiving towards that. I want to try to explain and be helpful. So feel free to go for it. I'll also pause and ask if anyone has questions periodically, but don't feel like you have to wait for that. Okay. So how do computers communicate? Computers communicate using this protocol on networks called Transmission Control Protocol, or TCP. So TCP is a protocol that allows one computer to make a connection to another computer. And this connection, you could think of that connection sort of like as like a pipe. You can send information back and forth from one computer to the other computer. It's a bidirectional connection. So from one computer, I can send something over to the other, and then the other computer can send something back. Or in the mail analogy, I can send a letter from one house to another house, and then mail from the other house back to the original house. And this connection, you'll hear me use this phrase a lot. It's called a TCP socket. So that's like the act of making the connection from one computer to the other, like that act and like that actual connection. So TCP is kind of like the mail carrier on our like housing diagram analogy. So it's a system that facilitates sending mail. So I've got a little animation here. So what I'm going to do is, let's say I want to send a letter from 100 Oak Street to 103 Oak Street. So what do I do? Well, I've got my mail at 100, put it in a little mail truck, I truck it over to 103, and I take it out. So there's an important thing, though, here that I'm glossing over, and I'm sort of just like hand waving, which is, okay, it's great that like you can send stuff from one house to another, but how do you actually know where to send stuff? Like if you think about it from the perspective of like a letter or like a package, you get sent out from the house, you're on the road. Like that package doesn't have anything, like it needs to have something inherent to it that says like where it's going, or else it's just going to kind of get lost in the postal service. It needs like a tracking number or an address. So typically this is how we solve it with mail, and it's very similar to how we solve it on the internet. So everything you want to mail from one house to another has to have an address. And if it doesn't have an address on it, then it just will get rejected. The postal service will be like, we can't send that. Same thing on the internet. So on the internet, addresses are what are called IP addresses, or Internet Protocol addresses. So these are unique identifiers for every network computer. So to break that down a little bit, IP addresses, and I'm going to put a little asterisk on this, it's not always true, but for all intents and purposes right now, you can think of IP addresses as being unique. So every computer in the entire internet that are all networked together all have a unique IP address. So if you were to attach that IP address to that letter or to that message and send over that TCP socket and say, that message, I wanted to go to that IP address, that's sort of what you need to tell it where to go. So an IP address looks like 4 numbers with dots in between them. Each number is going to be between 0 and 255. So I guess importantly, they're not going to be negative. They're going to be relatively small numbers. Here's a couple example IP addresses. So like 192.168.1.24. Also worth maybe pointing out, if you're kind of detail oriented, there's no like leading zeros or anything. It's just like if you have a 1-digit one, that's just 1 digit there. You can also have zeros in there. It's like 10.0.1.3. So I'm going to just mention real quick, there are other forms of IP addresses. In particular, for anyone who maybe has a bit of background on this, we're going to be only talking about IPv4 in this class. There's another thing called IPv6, so it's a bit more complicated. We're going to put that aside. I guess a lot of the stuff we're talking about today is a bit of a simplification. And if anyone's curious and wants me to go a little deeper, I can, but we don't need to go deeper. So I'm starting out at the surface. Yes, Joe.
just on that note, do most of those concepts still carry over to IPv4 that are um I know they open the like lengthen the addresses to accommodate
Yeah,
like more devices, right? Do the same concepts for the most part for IPv4
yeah.
work
So
for IPv6?
yeah, so you're touching on it. IPv6 is the other one. So IPv4, IPv6, all the same concepts translate. Really, the biggest difference with IPv6 from like a surface level is just the addresses are longer, so you can have more addressable computers. Like, I mean, if you think about it, four numbers, like it's not that like four numbers like this, all the different combinations is something like it's like a quadrillion or something combinations, or I don't know. I don't quote me on that, but it's like a large number. But it's the kind of thing where like it's not such an inconceivably large number that if like everyone had like 100 IP addresses for all their different like phones and laptops and IoT devices and smart fridges and all that stuff, like they it could be possible to hit that. And it turns out we've started to get close to that, and it's made some people nervous. So yeah, but like yes, in general, all the concepts we're going to talk about will translate. Just quickly thinking, yeah, I don't think there's anything that's like going to be grossly different that we're going to talk about. Does that answer your question? Great. Also, worth mentioning to all, you can get me starting to go down a path where I'll ramble for a while. If you like that, great. If you don't, feel free to try to rein me in. Um, okay. So we're going to update our little model here. So before we had houses with street addresses up top. Um, Now we're going to switch these out for IP addresses. And also switched out the houses for computers to try to move a bit more towards what it would actually be. So importantly, they act the exact same way. It's just sort of like switching those over for sake of the diagram. Okay, next. So we talked about IP addresses. We've talked about TCP. We've talked about TCP sockets. We've got a few more important concepts to talk about before we can actually start to get a feel for all the important bits. The next thing is what's called a network interface. So a network interface is sort of like a connection a given computer has to the internet. So if you think about this, maybe you have a computer and you're connected via Wi-Fi, and you also have like an Ethernet cord plugged into your computer. And you have like two sort of means by which the computer can access the internet. The way that typically works behind the scenes is each of those networking mechanisms, for lack of a better term, those end up being expressing themselves as like two different network interfaces. So importantly, each network interface has a different IP address. So what that means is one computer can actually potentially have multiple IP addresses. Usually, um, I would say like 95% of the time, you won't have to really worry about that. There'll only be one network interface that's like active where you're using, but it's important to realize that that is possible. Um, the way network interfaces are illustrated, remember we're going to do some exercises here and go into this a bit more, but typically you have like a few letters, lowercase letters, and then a number at the end. So here's a couple example network interfaces right here: EN0, WLAN0, ETH0, HAM0. So conceptually, in this sort of like mail delivering idea, think of different network interfaces, like different driveways or different like entries into each house coming from our main road. So something like this. This house here, only one entryway. So EN0, that's just that one interface. Down here, this one, 192.168.1.101, again, just one entryway. But this one up here, this upper right computer, it has EN0 and EN1. It's sort of like two ways you can get into that house. One is 192.168.1.102, so sort of the IP address assigned to that network interface. And then one is 192.168.1.104, so the IP assigned to that network interface. So what this means is if you wanted to send something from like 192.168.1.100 to this computer here, you could send it either to 102 or to 104, and it would still end up at the same computer, just sort of like which pathway you want to take in. Cool. Okay, so now is when we get to start to actually do some stuff, because you all probably don't want to just listen to me talk for like an hour, I'm guessing. And I don't blame you. So, what we're going to do is we are going to have you find your computer's IP address. We talked a little bit about that, what that is. So, in order to do this, we're going to use an application in the terminal that's a pretty common Unix tool. It's already installed on all of your Macs. So what I'm going to do is I'm going to open up my terminal. And then in my terminal, I'm going to type this command ifconfig. And I'm going to hit enter. You're going to get a lot of output. So what you're going to, well, actually, let me go to the next slide. I think it's got it better. Yeah. So what this is showing is ifconfig stands for interface config. Interface being your network interface. So what we're seeing in this command is information about all of your network interfaces on your computer. You're going to see there's probably quite a few. I probably have some more than all of you do, but there's still quite a few. So like LO0, GIF0, STF0, all these things. Also, by the way, don't feel like you have to follow along right now. I'm going to go through this, and I'm going to have a slide up, and you can all sort of go through it after that, if that's easier for you. Sorry, I should have said that at the beginning. So up here on the left, these are the network interfaces. So like on the left side, it says like the network interface and then a colon. And then on the right, next to INET, is the IP address associated with that network interface. So on a Mac, usually your default network interface is EN0. So I'm going to go find EN0 in the list. So I just scroll up a little bit. And then I'm going to find INET. And this is my IP address, 10.204.254.159. Okay. So there's a lot more in this. For now, we're going to ignore a lot of the extra stuff. If anyone's curious or wants to get into it more, we can, but it's not going to be that important for this module. So here's sort of the overview slide here. I would love everyone who can, who's on their Mac or has that in front of them, can go through and find their IP address using these steps and post it in the chat, the Zoom chat. One thing I will just mention, because folks have brought this up before, there's not really a security concern with sharing your IP, especially with like amongst a relatively trusted group. And also, like, for what it's worth, because of some stuff we're not going to get into, most of your IPs are not going to be publicly routable, so it's probably fine. But like, there's no real security concern. You don't have to be worried about that. So I'm going to give everybody a few minutes. Find your IP. It looks like some folks already have, which looks great. Most likely, if I had to guess, it's going to start with 192.168, or it's going to start with 10. Not 100% it will, but like probably like 90% it will. So give that a shot. And I'll give you a moment here.
Um, Sorry, I stepped away for a moment because apparently there's like police have a search warrant in my house for some reason. But yeah, it's kind of weird. What did I miss?
When did you step away?
Uh, like 3, 4 minutes ago.
I think we just were talking about ifconfig. So it's a command you can use to get the information about the network interfaces on your computer. What I have up here is generally what you need to do. Go through this, see if you can get your IP address and post it in the chat.
Okay, appreciate it.
Yep. And hopefully everything's okay.
Yeah, it just came out of nowhere, like because I'm literally like watching you, and I had like knocks on my door, like my sister's like, oh, the police there, search warrant. I'm like, search warrant for who? Like, it's kind of weird, but yeah.
I think we have the majority of people who have posted their IP address successfully. Terry, I see you're still probably working on it. That's fine. Anybody else have any difficulty or want me to take a look?
Yeah, I'm not seeing 192 as a start, but I'm seeing 10 dot something.
Yeah, that's still probably okay. So I guess it's probably be worth me talking a little bit about why all of your IP addresses start with 192.168 or 10 dot. Because like based on what I said before, you're probably thinking like these things are supposed to be unique across everybody. Like, what the heck? Like, why are these all so close? Like, what are the chances that they were just randomly assigned all within that 192.168 little bucket? Anybody like has that thought crossed anybody's mind, or am I just fishing and failing?
Does it have to do with like international codes?
Uh, no, but you're roughly on the right track.
Is it because we're all on private networks?
Yeah, there we go. So I didn't include it on my diagram, but how the internet actually is structured is more like it's more like a neighborhood street with cul-de-sacs is kind of a way you can think about it. So like little like side roads with a bunch of houses on the side road. So all of you are on computers that are on a little cul-de-sac street, like a little offshoot street off of the main street. And then I'm sorry if I'm taking this analogy too far, but then if you would imagine there was like a guard at the front of the cul-de-sac who is sort of like able to like look at everyone's like who wants to come into the cul-de-sac's like information and be like, you can go, or no, you're rejected, you can't come in. So the reason why is like why everyone's IP addresses are kind of similar is because it just turns out that 192.168 sort of prefix has been allocated for use in internal private networks. In other words, like those cul-de-sacs. So what's actually going on is like that network internal to the cul-de-sac is like its own little like thing. It's like every IP address in there is all unique, 100%. So in other words, all the IP addresses of all the devices on your home network are all unique. But there's some, I'm just going to use the word magic because I don't want to get too far into it, but there's some magic that allows that to work across the wider internet. I don't know if that helped or was more confusing. I'll say for what it's worth, that's totally above and beyond, not something you need to know for like the stuff we're covering in this module. But yeah.
Sorry, I know Max said that it's hard for him to see things in the chat when he's sharing, but people are putting stuff in the chat, and I think someone has a local host address or a loopback, but I don't know if
Yeah.
I'm completely right.
Someone's done some networking before. I did notice that. I just want to finish that explanation first. So Harley,
Sorry.
that one, no problem at all. Thanks for pointing it out. Harley, that 127.0.0.1, that's probably not the right address. Probably you found that under the LO0 network interface. You
Yeah,
wanna
I
look for
eventually found
EN0.
IP. I
Oh.
just have to scroll down.
Oh yeah, cool. Oh yeah, there we go. Excellent. We're gonna talk about that network interface in like 5 minutes, so we're almost there. Okay, sweet. I'm gonna keep moving forward unless anybody has any questions. Oh wow, I even made a slide. Fancy, fancy. Okay. So let's talk a little bit about what some of these network interfaces actually mean. So on a Mac, EN0 is the default network interface. I already mentioned that. Usually that means the network interface attached to your Wi-Fi card or your Wi-Fi chip. EN0 is something you'll see. So EN0, EN1, EN2, sort of like counting up like that. Those generally the way it works, at least on a Mac, is let's say you had like another network connection, like a USB Ethernet thing or something, or maybe like a second Wi-Fi adapter. That would show up as like EN1. And then if you had like a third one, it'd be EN2, EN3, and it's sort of like count on downwards. On Linux, it tends to be a little different, but generally the same kind of idea. You're going to see this sort of idea where like the number at the end sort of indicates like sequential network interfaces. But Deandra mentioned LO0, the local loopback interface, 192.171. Oh my gosh, spoke too fast there. 127.0.0.1. Let's talk about that. So that's another network interface that was in the list. So if I scroll up here, so it's probably going to be near the top. LO0. And if you look for the IP address in the same place, you'll see that it says 127.0.0.1. So this is a bit of a special network interface. And it's something that, at least as far as I know, every computer has. And by computer, I mean like laptop, cell phone, like smart TV, IoT device that's network connected. So this local loopback interface is a really cool little like innovation. And what it allows you to do is it allows you to make a request to yourself, which is kind of it's a bit of a weird concept. Like just initially, like why would you want to make a request to yourself? Like it's like sending mail to yourself. You wouldn't really do that. Like it's just sort of like a waste. But there are good reasons. So I guess before I get into that, though, let me explain how that kind of fits into this diagram. So the way I'm sort of illustrating this is imagine you have like a little path that goes back to the house, like loops around. That's why they call it the local loop back. So if I make a request, or I open a TCP socket on 127.0.0.1, it goes out that driveway and it just comes right back in again. So only one way that can go, that connection can go. So what's cool is you don't have to know your IP address. You can just on any computer connect to 127.0.0.1, that special networking address, special IP address, and it will always go back to yourself. But I was touching a bit on this before. Why would you want to do this? The biggest reason, and the reason that you'll use it in the rest of the class, is for development or testing. So stepping forward in maybe like a month and a half, once you've gotten a bit further into some of this stuff, you will be running little like web server applications on your computer, on your laptop. So these things will accept connections from the internet. And when you're testing these, you'll want to be able to run them on your local laptop, and then to be able to have something else connect to it, also running on your local computer. So two sort of programs running, and you want to test that they work together. In practice, though, that web server thing, that like server application, when it's actually out in the world, that won't run on your laptop. That'll run on like in a data center somewhere, in like a big server farm. So when that's running there, like you will actually, in practice, make a request to the IP of the computer it's running on in the data farm somewhere. So you'll like it's sort of like moving that web server somewhere else. So by using localhost or local loopback, what you're able to do is you're able to make a request to your local computer to test that whole interaction all locally before you take the result of your server and client, and you send that to the remote data center where it can actually run in like a more of a production-like aspect. Any thoughts on that? Any questions? Okay, I'm going to keep going. So I'm just rattling through a bunch of these networking concepts that are all really important. And I promise we're almost done, but we just got to get through all of them to sort of set that base foundation before we can move on. So the next thing we're going to talk about is called DNS, or the Domain Name System. This is a really helpful tool to make networks easier to navigate as a human. So computers don't really have to use this because it's pretty easy for a computer to just like know, oh yeah, okay, that computer over there has that IP address, that computer over there has that IP address. But as a human, do you want to remember that when you want to go to like your favorite website, you have to type like 152.24.13.5? Like, you don't want to have to remember that. You want some sort of like name you can give that computer that you can just like use that as almost like an alias to be like, that's where I want to go, and have that alias sort of like forward to that IP address. And that alias could have like a much nicer name, something maybe like google.com, for example. So DNS is how you accomplish this idea of like giving computers on the network human readable names. DNS, I could like probably talk about it for a bit. It's kind of complicated, but really high level, all you really need to know is thinking of DNS sort of like a big like phone book. So you have a bunch of names. You have a bunch of names in the phone book, and they all map to an IP address. And if you ever have one of these names, you have this phone book, and you can just at any point look up in the list. Okay, I have example.com. Let me, or maybe using the actual thing here. I have Jane Smith, so I go through here. I'm like, oh, there's Jane Smith right here, and that maps to this IP address. So that's sort of like high level what DNS is doing. There's also one more DNS name that's important to know, and I think Joe touched on it earlier. So 127.0.0.1, that local loopback IP address we talked about, it has a DNS alias that is present on every system that I know I've used. I guess in theory it could maybe not be, but it basically is everywhere. Called localhost. So if you were to instead of making a connection to 127.0.0.1, you make a connection to localhost, it'll go through that local loopback back around to your system, and the connection will go back to you. So in practice, you see localhost a lot more than you see 127.0.0.1. It's important to know that they both mean the same thing, but probably like 90% of the time, you're going to see that phrase localhost instead of 127.0.0.1. Okay, so I'm just continuing to add here to this street diagram thing. So I'm going to add some DNS names. So smith.com, jones.com, johnson.com. And I'm going to update. So what I did there is I just added above the DNS names for those IP addresses. I also just added the local host above the 127.0.0.1. So now sort of like all the IP addresses that have DNS names have them just like on the diagram for easy reference. I do want to quickly point out that there are some of these that don't have DNS names. So 192.168.1.104, there's no sort of DNS name there, and that's fine. There doesn't have to be a DNS name for every IP address. Like, it's sort of like an opt-in optional thing you can do. As a great example, all of your computers do not have DNS names associated with them. You could make a, well, I mean, probably, unless you have set something up crazy that I don't know about, but the vast majority of you probably don't have DNS names pointed to your local computers running on your desk. Okay. One more concept. I promise we're almost done with the me just talking, and then we can actually start to do some real stuff here. Ports. So the best way I have found to think about ports is, have you ever used one of those like walkie-talkies? Like you have a walkie-talkie, someone else has one, and you can sort of like press the button and talk into it, and the other person can hear it, and the other person can talk into it, and then you can hear it. So there's sort of like a back and forth communication that happens. Think of that back and forth communication very similarly like a TCP socket. So it's a connection from one computer to another computer. And in essence, like it's still, the walkie-talkie is like a connection. It's just like a non-networking based one. But if you're familiar with those walkie-talkies, you probably know that typically the way they work is they have a little channel switch on them. So what you can do is, if I'm on channel A and you're on channel A, and I say into my walkie-talkie something, you're going to hear what I say. But if you're on channel B instead, you won't hear what I'm saying. You only hear the things on that same channel. So why is this useful on a network? Well, you probably can think about like all the sort of stuff your computer is sending over a network. It's sending a lot of different types of data. And certain types of data should be received by certain programs on the other end on the other computer. So what ports let you do, they let you sort of discriminate certain traffic as to where it should go. So let's say I'm a program on the computer and I want to receive like maybe like web traffic, like network web browser related stuff. So what I can do is maybe I can go on a channel, let's just say A is for like web browsing stuff. So I'll go on channel A, and then somebody will open up a TCP socket, and then on channel A, on their little walkie-talkie on their side, they'll send me something on channel A, and then I'll be able to receive it on my end. And then I can send something back again on channel A. But importantly, as all that's going on, someone else, like even like this different processes on the other different computers, could send information on channel B, and it would be completely unrelated to channel A. It would be sort of like the wires wouldn't cross, the bytes wouldn't get mixed up. They would be like independent parallel bits of communication. So ports are sort of what we call these channels. They're sort of it's a way you can change, like pick which process on the other computer you want to receive the information, and keep information from getting mixed up between multiple processes on either end of the connection. So I had to deviate a bit from the mail analogy for that one, but I'm going to get back to it in a second and try to connect it. Before I do that, though, I will say that typically ports are the thing that is the most confusing that I'm going to talk about today. If anyone has any questions or want me to try to explain it again differently, let me know and I'll give it another try. Okay, I'm going to keep going. So channels match, communication is possible. B, A, they don't match, communication is not possible. Okay, so the way that I think in the mail analogy, it makes sense to think about ports is thinking about them as different people who live in a house. So maybe or computer house, it's starting to get a little muddy, but this computer house here, let's say Bob and Susie both live there. And every time a package comes in, that's Bob's. Anytime a letter comes in, it's Susie's. And you could think of that like that being not just two, maybe like 10 or like 100 different things, different processes, and also that being on every single computer in the diagram and like a different sort of arrangement. Okay. Those are all the really important concepts. So now we're going to do an end-to-end run through like how it would work to send something from one computer to another, touching on all the concepts that we just talked about. Okay, so here's our message we're going to send. Messages you send in a TCP socket are called TCP packets. So think of a packet like a letter or like a parcel or a package. It's like a unit of data you send on a TCP socket. So importantly, our packet has a to address. And it has a destination like IP address, or in our case, domain name, and then some data. So in this case, just some kind of arbitrary Latin text. So how does this work? So a second here, I got to resize some stuff. Okay. So the sender sends the packet to 192.168.1.100. Why 192.168.1.100? Well, because in the DNS table, setting it to smith.com, that maps to 192.168.1.100 right here. Oops, not right there, right here. There we go. So that's where we know to send to that IP address. So it's gonna travel along the internet. The packet's gonna go through the EN0 interface because it has the IP address of 192.168.1.100. That's the IP address associated with that interface. And then the computer looks at that packet and it sees it's addressed to Susie, so it goes to Susie. And that's very, very high level how the internet works. Kinda. So I skipped out a lot of stuff. I skipped over a lot of stuff because this could vary, like just this day, if you wanted to like really get deep into it, you could easily spend like weeks talking about it. Like it can get very complicated. And there's a lot of very clever engineering that has been done to solve a lot of very difficult and tricky problems in accomplishing all of this. However, 10,000-foot view for what you're going to need to know for the rest of this class, and generally as like a beginning web developer, this model I think will do you quite well. Okay. So we're at a bit of a stopping place here. I want to give a second for anybody to ask any questions they've sort of been holding on to, or if they'd like any clarification. Or actually, maybe the better way to do this. There's a React feature in Slack. I know Max used to do this. I don't know if he still does it. So if this is like weird and unusual, we can do something else. But like, can you give me a thumbs up reaction? So there should be like the little like React thing, or you can just give me like a thumbs up actually in real life if you're feeling relatively good about this. And then a thumbs down if you're not, maybe like a middle if you're not. I just sort of want to get like a general like feel here. How are people doing? Okay. Sweet. I'm seeing a fair amount of thumbs up, which is good. Okay. So I think we're going to keep charging ahead then, unless I hear anything otherwise.
I do have like a question.
Yeah.
So it's kind of a bit weird, but so for some reason, like when like me and my brother like try to like play a game together, it seemed like it doesn't work. Is that because like we're using like the same network, or is it because of like probably something different?
I think it'd be very hard for me to give you a real answer unless we dig into a bit of like what you mean by doesn't work.
Oh, so every time I try like to host like a room, and we both on the same Wi-Fi. We both use like Ethernet. So
Yep.
if each time I like host a room, and when he try to join, it doesn't let him join.
Yeah.
I don't know
So
what that's about.
it could be a lot of different things. Just on the top of my head, I'm gonna throw some stuff out there. I just want to say for everybody's benefit, none of this is like important for this module. This is just like fun information. There are things called firewalls that could sometimes be a problem. So in that analogy before with like the cul-de-sac, like think of a firewall like the guard in front of the cul-de-sac, like guarding what traffic can come in and out. If you're on the same network, that probably isn't a problem, but could potentially. Sometimes Wi-Fi networks have limitations around what kind of information you can send. So if let's say your network's like run by some big company, like they might want to try to avoid certain kinds of network information being sent because like it could be a security risk. The last thing that kind of comes to mind, just like off the top of my head, is it could be possible that like you are not actually on the same Wi-Fi network or something like that, or like there's some sort of like interesting network topology that like means that you can't actually make connections to each other. An easy way to check that, well, I guess yeah, it's kind of guaranteed with how it works. There's this thing called a subnet, which effectively is the beginning first bit of the IP address, and however many digits of it is sort of is varies. But if your IP addresses don't share a prefix, then you almost certainly are not on the same network. Note the converse is not true, but like if you're on the same if you think you're on the same network and your two IP addresses are completely different, that's probably a sign you aren't. Like a great example here is like maybe you're on mobile data or something, or you have like you're plugged into multiple network interfaces and like information's or networking is, I guess traffic is being sent on the wrong network interface. I don't know if any of that's relevant for your case. I'm guessing probably not, but I
No,
guess
no,
it's enough to think about.
no. It definitely answered like some like a few things like with the firewall because we definitely adjust the firewall to like make it like pass it. So like I know there's like
Yeah.
like you mentioned it's like firewall. There's like two different ones. Like this one for like what private and one for like public and something like that. So we enable
Yep.
like both of them and it still doesn't work in my case. So
Yeah.
but I just had to ask because I was curious to know.
Yeah. Well, we're actually going to do something in a few minutes, sort of is involves sending data between computers. So that could actually be an interesting exercise to try if you want to test it and see like, can I actually send data from one computer to another? But we'll get to that in a second. Yeah, good question. Actually, I guess we're doing that right now. Wow, nice foreshadowing there. Um, okay. So we're going to use a tool called Netcat to send messages back and forth between computers. And I'm going to put a asterisk on that because of everyone being remote, and this being like would be difficult to do in this complicated network scenario we're in right now. What I really would like, and what I've been able to do a few times in past cohorts, is to be able to have students actually send a message from one computer to another computer. So think like everyone like forms pairs and like people send messages to each other. But when you're in a remote context and you have to make those messages go through the internet and pass through all the different layers of security and things like that, that ends up being a difficult thing to do predictably. And predictability is kind of the name of the game as when you're a student and you want to learn stuff. So we unfortunately can't do that, but the closest we can get to that, what we're going to do instead today is we're going to use that local loopback network interface. So you're going to be sending a message to yourself right now, or that's what we're going to be doing. It's not as exciting, but Terry, you could have you could just as easily swap out with the command we're going to talk about in a second, localhost for another IP address, and then run one command on one computer, one command on the other computer, and then like it doesn't have to be on the same computer. And in your case, it might actually be cool to not be on the same computer to test that scenario. Okay. So again, I'm going to sort of very quickly show it, walk through it. I'm going to talk a little bit more in depth about it, and then I'm going to sort of put up a summary slide and everyone can go through it at their own pace. So don't feel like you need to rush through it real quick here while I have this up. So here's what we're going to do. You're going to have to open up two terminals, the two different terminal windows. I usually will put them side by side. So I'm going to take this one I had here, and then I'm going to go that, make another one. So I'm going to have two terminals. Guess I can, yeah, okay, that'll work. So in one terminal, I'm going to run this command here. nc-l, note this is an L, not a 1 or something like that. It's an L, 5678. So I'm going to do it in this one. And hit enter. And then in the other side, the client side, I'm going to type this command, nc-127.0.0.1.5678. So my other terminal here, I'm going to hit enter. And then once I've got this set up, what's happened here is now these two terminals are connected. So what this netcat command is doing is it's creating a TCP socket behind the scenes over the network, in this case, over local loopback, but that's not that important. It's still over the network. And the way netcat works is when I type things and hit enter in one terminal, so I'm going to hit enter here and watch this terminal over here, the lower one. You'll see it shows up over there. So what happened there is when I hit enter, it sent that data across the network and then back through, and then now it's over on this side. And it's a TCP socket, so it's bidirectional. So over here I can go and hello back, and that works too. So that's what we're going to have you all do. But before we go through that, I want to explain a little bit about these commands you're going to type, just to sort of disambiguate a few things and make sure everyone kind of has the fundamentals of how commands work. In the past, that's been a bit of a challenge. I just want to make sure that that's solid. Yes. Let's walk through the pieces of those commands. I don't know how much Max has exposed you all to terminal commands thus far in Careers in Code. My guess is probably not that much, but usually he does a little bit. Netcat, like a lot of other tools you probably have used briefly, is a terminal tool. So it works in the terminal application. A few other terminal tools you may have used, I really should have checked with Max to see beforehand, but things like Node or NPM or like Git or like CD or PWD or like mkdir, and hopefully some of that sounds a little familiar. I'm seeing some smiling and head nodding, so I'm going to hope it does. So netcat is just another one of those things. Importantly, though, netcat has a few different ways you can pass it information. They're pretty standard for terminal programs. We're going through this, though, because I don't think Max has actually talked about it in detail yet. And I just want to give you the context so that you can actually like understand what we're doing and not just like blindly copying what I'm telling you to. So there are two ways you tend to be able to give information to terminal commands. The first way is called a flag or positional, a flag or like a keyword parameter. And the second type is called a positional parameter. So the first one, this blue one, that's flags. The bottom one, the red and green one, that's positional parameters. So we're going to start with positional parameters. So it is about as simple as it gets. You type the command, so that you always do that when you're using a terminal command. You start your command by typing the name of the command, then a space. And then a positional command is just a space-separated set of words. So they're sort of like, it's sort of like an array, sort of like indexed. Like you have the first one, you have the second one, you have the third one. And other than just like the order they're in, there's sort of no extra additional context included in those positional parameters. Flags are a little different. So flags are sort of like, if I'm going to again reach the JavaScript analogy, flags are sort of like an object or like a key value mapping. So flags, the way that you typically use them, it's typically a parameter that starts with a dash. So how you indicate it's a flag, and either one letter or like a series of letters sort of name the flag. And then after that, the value of the flag. So in this case, this flag is -L, so the L flag, and the value of that flag is 5678. Also, it's worth pointing out that the order of flags typically doesn't matter. So if I have like two flags, so maybe like -L5678 -P1 or something like that, like I can flip the order, so I can do like -P1 -L5678, like I could flip them and it wouldn't make a difference. That's not 100% of the time true, but like 99% of the time that's going to be the case. I'll say for everything we're going to do in this module, that's going to be the case. The order doesn't matter for flags. Positional parameters, though, like the order is important there because like the only thing indicating where they are is just like their index. Okay, last thing on flags, I promise this is a bit of a digression. I just want to make sure you all have the background context. So flags can also, actually, I guess there's two more things. Sorry. Flags can also be longer and start with 2 dashes. So typically, if you have like a single letter flag, it's just a 1 dash. And if you have a multi-letter flag or like a word, you do 2 dashes. I don't know who made that up, but that's just how it works. It's just what the rules are. This is really the last thing. So you can also mix them. So importantly, it's possible to come up with some sort of ambiguous situations here. So, but typically what you do is if you have a command or a parameter that starts with a dash that sort of starts the flag, and then after that, the word after that becomes the value of the flag. So importantly, like in this case, 1 and world, those are sort of the values of A and hello respectively. But if I did like A positional 1, now the value of A is positional and 1's a positional parameter. So the order, there is some context here where like order is important, but I think the thing I want to say is the order of flags themselves, like the pairs, like A1, hello world, those don't matter. Okay. That is like, I think all you really need to know, like that if that all makes sense, I think that's probably about all you're going to need to know about terminal commands and like how the commands actually syntax wise work for a while.
Is
yeah.
this specific for Max terminal, or can it like is it universal for other OSs?
Great question. So typically the 3 sort of operating systems you tend to think about are Mac, Windows, and Linux. Mac and Linux both come from the same sort of computing heritage, what's called Unix. What I'm telling you here is good for all Unix stuff. So Linux and Mac. On Windows, I will be honest, I don't do a lot of work on Windows, but 95% of this also applies to Windows. There's some other, like, I guess, maybe really what's the better thing to say is on Windows, there's some more edge cases and weird cases. The Unix tools follow the rules a lot better than Windows tools do when it comes to command line things. So I'm not going to be able to give you like exact like differences just because I don't have all that in my head right now, but I can say for sure all this stuff will apply across Mac and Linux, no problem. Cool. Okay. So, oh yeah, one more thing. I need to stop saying one more thing if I don't actually mean it. So you might have noticed, maybe you already know this and Max has already talked about it. I just want to review it in case he hasn't, because it's very important with terminals. There's this little thing at the beginning of my terminal here, this little like theta tilde thing. For you in your terminal, it's probably something different, probably something longer. Maybe something that looks like this. So what that is, that's called a prompt. Your terminal prompt. You'll hear me use this word a lot. So what this means, when you see this thing, it means the terminal's ready for you to type another command. So if I type some sort of command here, trying to think of one that I can do that would what I actually typed here is not important. But what is important is I just type something and hit enter. You see here how I don't see my prompt? Like there's no prompt there. If I were to try to type a command now, it wouldn't work. Like I could just type it and like it wouldn't do anything. Like it wouldn't actually run the command. If you ever are in a terminal and you need to get out of your current running program and get back to the prompt so you can run another command, you want to press Control-C. It's a weird thing. It's just the rules that the Unix people defined years and years ago. But if you're in a terminal and you need to get out, sort of quit the current application and get back your prompt, you can hit Control-C. You'll see something that looks kind of like this. And now you have your terminal prompt back. So I bring this up because a really common problem that a lot of folks will run into is they'll have a command running, and then they won't know they'll try to run another command without exiting out and seeing their prompt again. So whenever you type a command, before you type it, just look and be like, is my prompt there? And if it's not, make sure it's there before you start typing. It's just a good thing to do to verify that everything's going to work right. So Joe asked, what about clear? So there's a command in the terminal. I'm getting the hint that some folks here have done some stuff in this realm before, which is great. There's a command you can run in the terminal called clear. So if I were to I'm just going to type some random crap here. And I type the clear command and hit enter, it'll clear my terminal. Importantly, though, in order to run that command, you have to have your prompt first. So if I'm in the middle of this and I type clear, well, actually, that's not the best example because it's going to store it. Let me do this. It's not going to work. I'm just giving input to the command that's currently running. So if you could use clear, but you need to get back to your prompt before you could use it in the first place. Does that make sense? Cool. Okay, now I think we're really actually done with the terminal stuff and the flags and all that. Any questions? And then we're gonna, what you all are waiting for, we're gonna send some messages with Netcat. Okay. So as promised, here's sort of back to the slide that we were kind of on before. So I'm going to walk through it one more time, and then I'd like everyone who has their Mac in front of them to give this a shot. I guess you should also mention, Netcat is not going to be installed on Windows. Well, you could install it on Windows, but it's not going to be installed by default. This tends to be a Mac and Linux only application. So you can't do this on Windows. You got to be on your Mac. Okay. So I'm going to pull out my two terminals here. So I have the server and the client. So I got to, importantly, just because it starts, the first step is one, I got to start the server and then the terminal first. So I guess the order here is important. You want to start the server and then you want to start the client. We'll talk about those terms client and server in a few days, kind of what they mean. Just for now, know that when you're doing this, you always want to start the server before the client. So nc-l5678, and my client, nc1270015678. And then I'm going to go, hello, hi. And I'm going to hit Control-C in both of them. Okay, so I'd love if everyone could give that a shot. If you have any, I'm going to sort of go on mute here and give you all a second. If you have any difficulty, feel free to mention something, flag me down. If you could give me a thumbs up or post in the chat or something, I just want to sort of get the status update of how everybody's doing. but I'll give you folks a few minutes.
Just a quick question. It's okay that our terminal is ZSH as in instead of bash.
You all, I think, know more than you're leading on. Yes, that shouldn't matter. I use bash just because I'm old school and it's what things used to be, but it shouldn't be a big deal.
Awesome, thanks.
Good question though.
My terminal's not doing it. I don't know what I'm not doing.
You want to share
Yeah.
your screen? Let's take a
Yeah.
look.
Sorry, just popped up. Can you see it?
Yep, I can see it.
Okay. So I typed the thing in up here and then down here, and it's not connecting. I can clear it and start all over.
Sorry, one quick thing. I just realized I forgot to make the Google Doc public. It should be
Oh,
public for
yeah.
everybody now. I'm really sorry about that. Okay, say that one more time. Yeah, it looks Shadia, I think, has the right idea. It looks like you might have a 1 and not an L.
Oh, you said that. It looked like a 1 in that picture. That also looks like a 1. Let's see. Oh, did I miss something? Yeah, I did.
So I'm gonna keep in mind you have to run your server to start with. So that top terminal, I think you want to hit enter up there first.
Oh, yeah.
And then on your bottom terminal, I think you were really close. You just, for one of those commands, you forgot the NC before the other two parameters. Yeah, that looks right. Give that a shot.
It worked.
There we go.
Thank you.
Excellent. Yeah, no problem. Saw someone had a message they left in the chat. Yeah, speaking of Windows, what are your thoughts on installing Windows virtualization on a Mac and using its terminal? How to differ from a regular one? So I will be honest that I have not used Windows in a serious capacity in like probably over like 12, 13 years. Like it's been a very long time. So I don't know if I feel like I want to answer this question definitively because I don't know if I'm going to give you like good information. But with that caveat, I'll say that it's gotten a lot better recently, but development on Windows, I think, tends to be rather difficult for web development. I guess I should make that clear. I'm a web developer. It's what I spend most of my time doing. It tends to be that most web development tools historically have been designed for Macs and Linux. Unix in general, sort of like that flavor or that sort of style of thinking about computing, that's kind of what powers the internet. You will tend to see like high 90% percentage of servers run some flavor of Unix, and a pretty large portion of those will run Linux. So what that means is, as a web developer, you're often developing applications that have to run on these servers. So to have locally an environment that's very similar to that can be a real advantage for you, like as you're doing your work. It's not to say there aren't advantages of Windows. I'll say that like it used to be, if this was like 4 or 5 years ago, I would have told you like don't even try it. Like it would be you would have like an incredibly poor development experience on Windows and it wouldn't be worth it. However, these days it's gotten a lot better. There's a lot of interesting tools like Windows Subsystem for Linux and stuff like that have made it a lot better. However, having said that, I still have not been able to really get a good development environment going on Windows and haven't really kind of wanted to either. I have a coworker who like does all his like web development work on Windows and seems to be like relatively productive at it. So like it's not to say that it can't be done. Like it probably can be done. If you have the Windows knowledge, it's probably fine. I'm just sort of like biased because I just haven't used Windows that much. So it's not worth me to put in the effort to figure it out at this point. And there's, to me, like not really a real advantage to developing on Windows over Linux or Mac, other than I guess maybe you could like don't have to buy a Mac, but if you don't do, just run Linux. I think whatever. I'm probably super biased, but that's kind of my perspective on it. Hopefully that was helpful. um.
Can I share?
Okay. Yeah, go for it.
Because I'm having a little trouble. Alright, so. So these are my two. Before I pressed enter, I just wanted to run it by you. I did put L instead of 1, but is
Yep.
there any one of these that I need to press enter to first?
Yeah, so the server, the one you have at the bottom, that's got to start first. As a general rule of thumb, you need to sort of start the server before you start the client. So now if you hit enter on your on your client terminal, so the one on the left now you should be good. So try typing, yeah, there we go.
Yeah, I believe I did it the first.
Yeah. So as maybe a bit of an analogy that could help explain why that wouldn't work. Imagine if you tried to send a letter to a house that hadn't been built yet, like a vacant lot. So kind of what I'm hand waving a little bit here, but like kind of what you're doing there is you're trying to connect to a thing you haven't created yet. And because that first letter is what's establishing it, because there isn't anything there to listen, the client thing sending that first letter is like, there's nothing there. And it just kind of like quits. So that's why you have to start the server first. You have to have something that can receive your message before you send it.
Makes sense.
Cool. Anybody else have any questions, thoughts, need any help? It looks like in general for folks, this is going relatively well, which is good. Okay. Yes. Sorry, I'm looking ahead to try to think I don't want to start something because we need to take our break soon and have to get halfway through it and take the break in the middle. So I'm trying to decide, do we take the break now or do I try to crash through it and take the break afterwards? And I think probably should take it now, but attendance is a good idea. So I haven't done this style of attendance before. Last time it worked differently. So do you all have the proper link to put in the information you need, like the form you have to fill out already? Or do you need me to like dig that up and post it? Okay. Sounds like yes. Yeah, so I have to give you a keyword. Oh gosh. Let's do like you know what? Let's give it a theme. Let's go like client. That's the keyword, client. I think that's all you need. So if you fill out the form with that keyword, you should be good to mark you're here. Okay. So I think what probably makes sense, let's after you've all filled that out, let's take our break, and then when we get back, we'll sort of do the final bit for today, the final lesson bit. And then at the very end, we've got like a larger exercise to go through with it, some more like you actually doing stuff. Keyword again is client. So this word right here. So I think with that, let's take our break now. Let's come back at like maybe like 7:15. I think it's about like 20 minutes usually, right? I think. Okay, if no one calls me out, that's what it's gonna be. Oh, usually like 25. Okay, let's do 6:20 then. So we will take a break. We'll be back at, or sorry, yes, 7:20. I can't do math, so back at 7:20. Okay, I'm gonna pause this. Wait, no, I need to. There we go. I'm really like, I remember today because Joe, you posted the reminder, but also like it's the first day, but like once we get back from break, I'm gonna forget at least one day, and people are gonna be frustrated with me. I'm gonna try my best though. Okay. Cool. So hopefully you all had a good break. So very quickly, we're just gonna do a quick high level overview of what we talked about before, just get everyone back in that mode. And then we're gonna do the sort of final part of today. We're gonna actually do some more interactive exercises, and that should be a little bit more engaging and won't just be more of listening to me talk. Okay, so we started today talking about networking. Networking being connecting multiple computers together and sending information between them. We talked about TCP and TCP sockets, how you sort of have two computers that talk to each other over that shared connection. We talked about IP addresses, how every computer on the network has an address that's all unique. We talked about DNS, so how you can give names to all those addresses. So you can do things like, say, instead of go to 192.168.1.5, you can say go to example.com. And then we also talked about ports. So a port being like those communication channels, like those that walkie-talkie analogy I gave. And then finally, we actually put some of that into practice. So most of you, if not all of you, were able to send messages to yourself with Netcat, which is pretty cool. So we are going to take this up to the next logical step. Actually, before I do that, though, I do want to quickly break down what these commands mean, these netcat commands. And I didn't actually do that. And I realized after I went on break, I should have mentioned this. So netcat takes two types of parameters, either positional or flags, or it can take both of them. If you give netcat the -L parameter, that means listen. So when you give a netcat -L, and then you give it a number, this is actually the port it's going to listen on. It's going to listen on that port for incoming connections. And then the client side, when you don't give it that -L, by default, netcat will connect. And when it does that, it will make a connection to the given host, this given IP, on that port. So if anyone wants to play around a bit more, you could actually notice that if you change this port in both commands, as long as you keep it the same number, your communication will work. But if you change them, it won't work right. Either one side won't connect to the other side, or like messages won't show up on both sides. So that's what's actually going on there. One other thing I want to mention quickly about ports that I should have mentioned before, but I guess I just forgot to say it. So ports are always numerical in TCP. They're always positive, so they're not kind of a negative port. And they're always an integer between 0 and 65535. So the maximum port, like the maximum value you can put there, is 65535. The minimum value is 0. Also, certain ports are sort of like just automatically defined by default to handle certain types of communication. So we're going to talk about this tomorrow, but as a quick little preview, tomorrow we're going to talk about this thing called HTTP, which uses port 80. So all HTTP communication happens on port 80. And you could do it on another port. Like, there's nothing saying you have to do it on port 80, but it's sort of like by convention, that's the port you use, so that the server on the other end, the other computer you're connecting to, sort of knows like where to listen for your incoming connection. Cool. Okay. That out of the way. If no one has any questions. Next, so we've talked to ourselves. That's great. Effectively, there's been a human on both sides of our connection. So the server is sort of controlled by us, and the client is controlled by us. So what you're sending back and forth between the two different terminals is just like whatever arbitrary information you want, which is cool. Like, it's cool to see that actually work. But importantly, that's not actually how it works in the real world. So in practice, in the real world, you are going to spend a lot of time talking to machines, not talking to other people. So what do I mean by that? Well, I mean that server, instead of being a human on the other side that can like understand English and context and all that fun stuff, will end up being a cold, hard machine that only understands logic and does exactly what it's told to do. So in order to facilitate this, we can't just send like English to a machine. There's some cool, fancy new technology these days you might have heard of that computers can like kind of start to understand a bit more contextually what's going on with English, like things like large language models. Putting that, like, all that aside for a second, it's totally not something we're going to talk about. But like, generally, computers are not good at that. That's like a difficult thing for a computer to do. When you want to tell a computer what to do, you want to give it like clear, easy to understand instructions. And the easiest way to do that is to give it those instructions in a format that it can understand and process. So typically the way this is done, the easiest way, there are maybe some other approaches, but typically the way this is done is with what's called a protocol. So I've actually said that word before today, TCP, Transmission Control Protocol. So it was in that acronym. But I think it's worth actually officially defining this. So standardized format that can easily be parsed, understood by any computer, and hopefully humans too. So what this means is, as a human, you send information to the server, to the other computer in this protocol. And because it's in the structure that the computer can understand, it can process it, understand your intention, and then service whatever request you're giving it and give you back some data in response. Because the server has to understand the protocol and the client has to understand the protocol, they need to be like speaking the same language. You can't have the equivalent of like one person speaking French and one person speaking English. Like that's not going to work. You need to have like the same language being spoken by everybody. So, I have put together on the internet. Actually, how did I? Well, okay, I guess I'll come back to that in a second. I guess I should just talk about this example protocol first before I start to get all more abstract with it. So here's an example of like a really simple protocol. Now, I want to make it clear, this is like something I just invented. This isn't like a real protocol. It's just sort of like something very simple, like give you an example. But this example protocol, there are sort of two parts. There's a question identifier and a word. And if you use this protocol, you can ask a question to a computer. So there are three sort of possible forms of questions. FAV translates to what is your favorite blank. MAN is how many blanks do you have? And then IST is what blank is it? And that word sort of goes in the blank. So the idea here is by doing it this way, you are making it very unambiguous for the computer. Like you could maybe try to ask it a question and use slightly different grammar or phrase it a little bit differently. And the computer wouldn't be able to understand that. But with these three formats, you have to fit your question into one of those, and then you ask it in that format, and then it unambiguously knows that's what you're asking. In response, so after you send it that, the computer thinks a little bit, and then it sends you back a response with ANS, which is the answer is whatever. So as an example here, like FAV programming language could be like, what is your favorite programming language? Sort of how that breaks down. I'm just realizing, Joe, you had asked a question in chat that I totally missed. I forgot to reopen chat after the break. Is port 80 reserved? So yes. So I guess kind of touching back on or going back to what I was saying before, there are some ports that are sort of used for specific types of traffic, types of communication. Port 80 was that example I gave for the HTTP. In general, like that, if you see something that is listening on port 80, it's going to accept HTTP traffic. There's nothing that like necessarily enforces that. Like you could listen to other stuff. Like it's sort of like a convention. So I think like, yes, you could say it's reserved, but I think it's just worth like, I just want to unpack a bit on like what that word reserved means. Like it means that by convention, you should be listening to HTTP, but there's nothing that's actually enforcing that. Cool. Okay. Back to what we were talking about before. Sorry about that. I should have caught that one earlier. So I kind of got a little excited and jumped in a little fast, but you may have caught that I wrote a server that understands this little toy protocol thing. And I have it running out on the internet. So importantly here, this is a server that's not running on your local system. It's located at careersencode.xyz, a domain I purchased and set up with some stuff running. And then it's on port 4000. So what we're going to do is I'm going to sort of go through the process of connecting and asking it a question. And then I'm going to go through it, and then you can go through it afterwards. But kind of the hope here is to sort of like start to give this a shot of like, okay, so the next building block is we've used Netcat, we've communicated a bit locally. Let's start to actually talk to like something a little bit more real, so moving more in the real direction. Okay, so importantly, for this, we only need one terminal because we're only connecting. We're not like listening and connecting to the listening thing. Like we're just connecting. So we only need one terminal. And so I'm going to use the same form of netcat I used before. So NC, and then the sort of IP or the host name to connect to in the port. So careersincode.xyz 4000. And hit enter. So then I have a little demo here. I'm just going to do exactly what my little terminal demo example here does, just to go through that. So I'm going to go FAV Apple. So if you remember from before, this translates to what is your favorite apple. I'll put that up again so you can like look at it and actually see it. But just by memory right now, what is your favorite apple? And the answer back is Macintosh. So importantly, like I didn't go sneakily type that over on the side here. Like that came back from the computer up in the cloud somewhere. And then when I'm done, I hit Control C and I'm good. Worth also mentioning that you can actually ask it multiple questions in a row. So you can go like Apple, could do this one again. So you can like, you don't have to hit Control C between each one. You can like send off like a bunch of them and it'll request response back to you. Cool. Okay. So, we are now going to, this is kind of, so I guess I should say, these exercises, this is sort of the rest of the class. We have a bunch of these sort of like questions to ask. We're going to go through it. We're going to try it. We're going to hopefully have everyone do it successfully. And then we're pretty much done. So that should be good. Okay. So kind of just like I said, each of these exercises, we're going to send some data to the server I set up. All these use the protocol I outlined. I just have this screenshot of this slide peppered through each of them. So you have that as reference. So you can look at them. Also, again, it's at careersincode.xyz on port 4000. So I'll actually put that in chat as well, just so we've got that for reference. Okay, everyone ready? Like, so I guess like the goal is I'm going to show you this, give it a shot. If you can, just follow that convention, give me a thumbs up reaction in Slack, or not in Slack, in Zoom, to let me know that you've it's worked well for you, or give me a thumbs down, or just sort of like give me some feedback as to how it's going. And then I'll give folks a few minutes, then we'll talk about each one. So here's the first one. What time is it? So give that a shot. I'll give you a few minutes. So I think also I should say, I don't know how to say anyone's names. If I screw up your name, I apologize. I think Desiree. Why does it say 1140 instead of 740? Great question. So I'm going to give folks a few more minutes, and then I'll go through it and I'll talk about it then. But great observation. Okay, folks, so I saw some thumbs ups, I saw some stuff in chat. Does anyone have any questions or want to take a look at their exact screen if they were having some difficulty or something? If not, I'll go through it, but I just want to give anyone the opportunity. Okay. So for this one, I'm going to do NC Careers and Code 4000. And then what time is it? So the way I sort of say that phrase, looking at the translation here, is what blank is it? So that's IST. So IST, and then the blank is time. And then if I hit enter, I get back this. The time is 23:42:57:571Z. A few folks asked in chat, why does this say 11:40 instead of 7:40? Which is a really good question. So I want to call your attention at the very end. There's that Z, that character. So in computing, almost always you think in UTC time. I don't know how familiar folks here are with like time zones and weird time complexities. I will say that as you get further into engineering, you will almost every engineer eventually comes to the opinion that time is crazy and complicated and hard to understand. It has crazy rules that are inconsistent. If you don't believe me, I'll post a thing in Slack afterwards. It's like 50 falsehoods programmers believe about time. Time is like way more complicated than people naively think it is. Because of this, there are to try to build applications that take into account crazy time complexities. Like a great example, you might think time always moves forwards. Most people would be like, yeah, time moves forwards. That you could feel like you could assume that. Here's an example where time doesn't move forwards. Daylight savings. So daylight savings, you sort of have like a point, and then you end up skipping an hour to sort of like move an hour forward, or you go and back and actually repeat an hour. So there's actually like time can happen more than once. You can sort of go to a point and then like go back and repeat it. And that's sort of how like daylight savings takes care of that like shift back and forth. So you can have time and then have it go back, and that's like totally fine. Okay. I could really go down a whole thing. I don't want to overwhelm you all with like crazy time stuff. But the reason why I'm bringing this up is usually engineers don't want to have to think about all this. What they want in time is what's called monotonically increasing time. So think of it like a number that increases always and increases at a steady rate. That's kind of what like engineers want out of time usually. That ends up being like a very predictable and easy thing to work with. But what's unfortunate is all our crazy time systems that humans have developed to make time make sense to our crazy brains doesn't make that easy. So UTC time is sort of the closest to that exists, which is UTC sort of is like on the time on the prime meridian. There are sort of no like daylight savings or crazy shenanigans like that. It is time that always advances forward. And generally, when you talk about like times in engineering, you talk about UTC time with very few exceptions. So why am I going down this whole path? Well, it was asked, why does this say 11:40 instead of 7:40? And the reason is because this is in UTC time, and that Z at the end indicates UTC time. That's just like a convention. Yeah, Zulu is sort of the military people, what they say for it. So in general, like that's sort of the time you think in. Of course, like if you know a user's time zone and you have a crazy library locally, it's relatively trivial to convert from like user local time is what they call it. So like for me, like local time, and I'm assuming for all of you, local time is 7:47 p.m. But like it's because of all the weird inconsistencies, I guess long story short, because of all the weird consistencies, UTC time is what people tend to use, and that's what I had available to me when I wrote this, so it's what you all get. But I'll see if I can dig up that article, like that like 50 falsehoods programmers believe about time thing. It's really the first time I read one of those articles, I was like really surprised. I thought I knew more than I did. So it might be an interesting read for you all if you have a few minutes. Okay. So anyway, that's sort of that example. Sounded like there weren't any questions, so I'll keep moving forward. Thank you for humoring me on my time rant. If you want to, we're probably gonna have an office hours this weekend, I would guess. If you want to ask me any other weird stuff about time, feel free and I'll give it a shot. Okay, next one. How many CPUs do you have?
Can you see the questions that we ask?
Say that again?
Can you see the questions that we ask?
No, well, I guess in theory I could. I'm not like looking at it right now or something. This is all on our system. Just do it, and if you're having trouble, let me know. Otherwise, I'm just gonna assume you did it. So, oh, and I guess the
Because
other
I
thing,
was asking crazy random questions. So
yeah,
seeing if I should stop if you can see.
if you ask crazy random questions, it's just gonna basically be like, sorry, I can't do that. I can't handle that question. But like it's a good exercise. Like if you try to ask it that question, or even try to just like type something that's not in the protocol, see how it responds. It's relatively bulletproof, so don't feel like you're going to break something. Although famous last words, someone will end up breaking something, but that's great. Good learning experience. But like it's generally the kind of responses like the way I built this is like the kind of responses you're going to get are going to kind of be similar to the type of responses you get in real systems. So if you give it data that's like garbage, it's just going to be like, I can't understand you. And if you like let's say you only gave it like the first word, you like missed the second word, it would be like give you a message like, you missed the second word, this is really important, I can't process your message. So okay. I'm gonna, I think, go through this one, unless anyone stops me or wants a few more seconds. Okay, how many CPUs do you have? So I'm gonna look up how many blanks do you have and do MAN. MAN CPUs. I have 1 CPU cores, which is nice and grammatically correct. I think when I wrote this, it was running on a dual core machine, and then I downgraded it to save some money, and I forgot to intelligently make that plural or not. Okay, next one. What is your favorite operating system? Okay, let's give this one a shot here. So we go FAV operating system. Answer is Linux. Okay. We'll do one last one, I think. I think folks generally seem to be getting this. I mean, it's not really that difficult, but the goal here is more just like connect all the dots, make sure everything's working. So let's do this one last. What is your favorite flower? Okay, so you go FAV flower, get violet. Okay, so that's all we have for today. I don't know if anyone has any questions or wants me to go through anything in particular again. But otherwise, I think we're pretty much good. Yeah, I think so. Tomorrow we're going to talk about HTTP, which will be a lot of fun, but that's a whole thing, so I'm not going to get into that now. Yeah, I'll say if anyone's like feeling adventurous and is like they're like wanting me to move a little faster or like have any feedback for me, there's that form that I think Max has brought up in the past is like the like 30-second feedback form thing. Feel free to fill that out. I'll take a look at anything anyone puts in there. And also, because you all have access to the slide presentation, like you're welcome to like look ahead at future slides. I'm gonna go through them kind of at like a steady pace, but like you can look ahead if you want. Like they're relatively like self-explanatory. I'm doing a lot of reading off of slides so they can be a reference material for all of you. But yeah. Also, if anyone like really gets far ahead, there's actually some stuff at the very end of the presentation we're probably not going to cover, but like is sort of bonus material. So we'll see. But usually I don't get a chance to cover it. Kind of depends on how things go. But okay. Anything else from anybody? Okay. I think we're done for the day then. Have a good evening, folks, and see you tomorrow.